Good day, everyone. Our topic for today is all about analysis of variance, two-way classification. But before that, don't forget to like and subscribe to this channel and hit the notification bell for more updates. Also, you will find different subjects in this YouTube channel. Just select the playlist section. And now, let's proceed to our main topic for today, which is all about analysis of variance, two-way classification. The two-way analysis of variance incorporates two independent variables in the same analysis, thus allowing a more powerful test of differences among means. In this two independent variable research design, one of the independent variable is set up in columns and the other in rows to form a block of cells. A cell is a combination of treatment conditions that is unique to one group of subjects, or where a row intersect a column. Example number 1. Miss Cruz conducted an experiment designed to compare the relative effectiveness of three methods for learning algebra. 15 males and 15 females are divided into three groups, with 5 members each and taught by three different methods, namely study group method, computer-aided method, and game simulation method. At the end of the experiment, each student is then given a test. So these are the scores of the students. The teaching method or the methods are study group, computer-aided, and game simulation. For the sex, we have male and female. For the male, it is written in the table the scores or their scores for the study group, computer-aided, and simulation or game simulation. For the female, we have this one, their scores for the study group, computer-aided, and game simulation. Now, the questions are these. Construct the ANOVA table. B. Is the interaction significant? C. Are there differences between methods? D. Are there differences due to the sex of the students? So these are the questions to be answered. For step 1, determine the null, the alternative hypothesis, I think it's hypothesis, and the computation. For the null hypothesis, the null hypothesis 1 is there is no difference due to the method used in learning algebra. Hypothesis number 2, there is no difference due to the sex of the students. Hypothesis number 3, there is no interaction due to the method used and the sex of the students. So we are doing three hypotheses. For the hypothesis 1, we are comparing the three methods. For the hypothesis 2, we are comparing the difference of the two sexes or the male and female sex about their mathematics performance. For HO3, there is no interaction, meaning to say we are looking for the the difference or the interaction in the sex and the method used. So in the HO1, we get the difference or we compare the three different methods. In HO2, we compare the sex. And HO3, we compare the interaction between the methods and the sex. For the alternative hypotheses, there is a difference or there is a significant difference due to the methods used in learning algebra. For the alternative hypothesis 2, there is a difference due to the sex of the students. And for the alternative hypothesis number 3, there is a interaction due to the method used and the sex of the students. So, in the teaching method, ang ginawa lamang or what we've done here is that we get the squared of the study group scores, the squared of the computer aid scores, and the squared of the game simulation. Okay, so for the R1, 30 times 30 is 900, 37 times 37 is 1,469, and so on. So you will just multiply all of this by themselves. Okay? Then after that, add the total of the first group for the male, which is 180, the total of the second group for the female, Again, male for which is 149, and the third group for the male is 152. The same is true with this one. So you need to add all of this, add this, okay, and this one. Okay. After that, you need to get the total 180 plus 149 plus 152. Please write it on your notebook. 175 plus 126 plus 130. Please write it and answer it on your notebook, because after this we will answer them, or we will do the computation for the next step. Also in this portion, you need to add 180 and 175 for the first column, 149 plus 126 for the second column, 152 plus 130 for the third column. And then on the other hand, you need to add all of this also for the first column, add all the R2 squared for the second column, and R3 squared for the third column. After adding them, so you may pause this video while you add them, or you may go back to this video after adding them. Okay, now let's proceed. For the summation of R1, okay, it is equal to 481. So where did I get this 481? That's 481 is 180 plus 142 plus 152. Okay, that's 481. For the summation of R2, that is 175 plus 126 plus 130 is 431. Summation of C1 is, so these are given, okay? These are given. These are, what do you call this, constant, okay? You just need to fill in, okay, depending on the number of, or the given numbers. For the EC1, that is the total of this study group. So 180 plus 175 is 355. And then EC2, 149 plus 126. EC3 is 152 plus 130. For the EC1 squared, that is, you need to add all of this. So that is EC1 squared, EC2 squared, and EC3 squared. Okay? For the number, or the total number of the respondents, we have 30. For the number of rows, we have 2, that is male and female. For the number of C, that is the methods, we have method 1, 2, and 3. And for the number of N, each experiment, there are 5 members, right? So we have N, capital N, R, C, and N. So it is important that you have this data, okay, because these data are very important in our next computation. Okay, I hope you screenshot this so that you can compare later the computation. Okay, now we will get the summation of x. For the summation of x, we will add summation of C1, C2, and C3 depending on the number of C. Okay, so in our given, we have only 3 C's. So we have summation of C to summation of C3 C3. And then just write the data that we had computed a while ago, and the total is 912. For the summation of x squared, that is summation of C1 squared, C2 squared, and C3 squared. And these are the data that we computed a while ago. So we have 28,942 for the summation of x squared. So we have additional two data added to our given. Now, for this step 2, find the total sum of squares. So that is the SST, where the formula is summation of x squared minus quantity summation of x squared over n. The n is capital, therefore we will use number 30 as the value of n. So we have 28,942 as we computed a while ago, minus the summation of x is 912. This is what we had computed a while ago, squared over 30. So 912 squared divide 30 is 27,724.8. Okay? If the decimal point is, or decimal places is too many, you may round up your answer to nearest hundreds. And then subtract the 2 and you will get 1,217.2 for the SST, or the sum square total. For the column sum of squares, what you're going to do is to follow this formula. SSC is equal to summation of C1. We have this data, right? squared over n times r. This is the number of respondents per experiment, and r is the number of row. So we have, in our given a while ago, we have 2 rows, and n is equal to 5, so that's equal to 10. Summation of C2 squared over n times r, and so on, depending on the number of C, minus summation of x squared over the capital N, which is 30. So, in our given, we have 355 as the total of C1, so squared, 275 for C2, 282 for summation of C3, and 912 for the summation of X. So we have N, which is 5 times R, which is 2, 2 columns, so 10, 10, 10, and 30 for the total number of respondents. No? So you can check if your if your answer here is correct by adding all of this. So 30 is the answer. Okay. Now, just get the 355 squared divided by 10, and you will get 12,602.5. 275 squared divided by 10 is 7,562.5. 282 squared divided 10 is 7,152.4. And 912 squared over 30 is 27,000. I think this is sumobra. Wait lang. This is not correct. 27, is that 27,000? Let me see. Okay. Sumobra. So it's, sorry. Let me first edit this one. Okay. So that's it. 27,724.8. And then add all of this, all the numbers to summation of C1 to summation of C3, and you will get 28,117.4 minus 27,724.8. Is it possible that we will get negative here? No, it is not possible. So it should be positive. So the answer is 392.6 for the difference of the two numbers. And now, for the step 4, find the row sum of square. For the rows sum of squares, we have formula summation of r. We already computed this one. Squared over n times c. C is the number of columns. So we have 3 columns. And then we have summation of r2 squared over n times c. And then summation of x squared over n. Again, you will add the 2. And if it is the same with the capital N, your answer is correct. So we have 5 times 3, 15. 15 plus 15, 30, correct. For the summation of R1, we have 481 that we computed a while ago. So we have 481 squared over 15 is 15,424.07. And 431 squared over 15 is 12,384.07. Minus 912 squared over 30 is 27,724.8. Add this 2 minus 27,724.8 and you will get 83.34. So we completed SSR, SST, and SSC. Now we will proceed to the interaction sum of the square, where the formula is SSI equals SST minus SSR minus SSC minus SSE. Okay. But first, let us identify what is SSE. Okay, so for the SSC, we have summation of x squared minus 180 squared over 5 plus 149 squared over 5 plus 152 squared over 5 plus 175. Where did I get 180, 149, 152? These are the total of for the male, right? For the male, we have 180 for the experiment 1. Experiment 2 is 149 and experiment 3 is 152. You can go back to the part of the video showing the table so that you can check if these given are correct. 175 for the female in the study group, if I'm not mistaken. 162 for the computer aided and 130 for the, I forgot the one, simulation game. Okay, now, you just get the division of 180 squared over 5 and you will get 6,480 and so on. And then for the summation of x squared, it is already given in our problem. So we have 28,000, I mean in our computation a while ago, so we have 28,942. And then add all of these and then subtract it to 28,924 and you will get 720.8. Again, it's very impossible that you will get a negative answer. So we're completed for the SST, SSR, SSC, and SSE. So we can now put them in our formula for the SSI. So subtract them, and then the answer is 20.46. Find the sum or the within sum of square. For the within sum of square, we have SST minus quantity SSR plus SSC plus SSI. So our computed SST is 1217.2. For the computed SSR, 83.24. For the computed SSC, 372.6. And for the computed SSI, 20.46. Just add first the what's in the parentheses and then subtract it from 1217.2 and you will get 720.8 for the value of the SSW or the within sum of square or sum of squares within. For the degree of freedom, for the rows, we have R minus 1. For the number of column minus C minus 1. Interaction rows minus 1 times column minus. So we have R minus 1 times C minus 1. So these are the formula. Column in a sample minus row times column and minus RC. And the number of sample minus 1 is equal to N minus 1. So these are the formula for the degree of freedom. So N minus 1, N minus RC, R minus 1 times C minus 1, C minus 1, and R minus 1. So, for that one, we have the following 2 minus 1 is 1. For the C, we have 3. 3 minus 1 is 2. For this one, R minus 1, so this is 1 times 2. The answer is 2. For the N minus RC, 30 minus 6. RC is 2 times 3. So we have 6. 30 minus 6 is 24. For the N is 30 minus 1, 29. So for this one, for the MSR, we will get the mean squares. MSR has a formula SSR over R minus 1. SSR is 83.34 over 2 minus 1. R is 2. So we have 83.34 because it's equal to 1. For the MSC, we have SSC over C minus 1. So we have the computed SSC is 392.6, and for the column, we have 3 minus 1, so that's 2. 392.6 divided by 2, the answer is 196.3. For the MSI, we have SSI over R minus 1 times C minus 1. The computed SSI is 20.46. For the R minus 1, we have 2 minus 1 and 3 minus 1, so we have 1 times 2. So we have 2, 20.46 divided by 2, and the answer is 10.23. For the MSW, SSW over N minus RC. So we have 720.8 for the computed SSW over 30 minus 6, so that is 24. So 720.8 divided by 24 is 30.03. For the F1, ayan, this is the final step. Find the F ratio and complete the two-way Anova test. For the F1, we have MSC and divide MSW. So we have computed here the MSR, MSC, MSI, and MSW. And then for the MSR, divide MSW. For the F2 and F3 is MSI divided by MSW. So for the F1, we have MSR divided by MSW. So that is 83.34 for the computed MSR divided by MSW, which is 30.03. And you will get 2.78. For the F2, we have MSC divided by MSW. So we have 196.3 divided by 30.03, and you will get 6.54. And for the MSI, F3, we have MSI divided by MSW. So we have 10.23 divided by 30.03, and you will get 0.34. As you can see, all of this F ratio is over MSW. So nag-iiba lang yung sa taas, numerator. Okay? So it becomes MSR, MSC, and MSI. So we have now the value of the F ratios. So we have F1, 2.78, F2, 6.54, and F3, 0.34. For the critical value at 0.5, the problem doesn't have any critical value given. So, I mean level of significance. If the problem doesn't have any given level of significance, you will use automatically 5%. If it is educational, if it is medical or more on medicines, that is 1%. So for the F distribution table, so for the DF, for F1, we have the formula. Um, R minus 1, comma, RC, quantity N minus 1. So we have R, which is equal to 2. R is 2 times 3 for the C column. N is 5. Just do the operation. So we have 2 times 3, that's 6. 5 minus 1 is 4. 2 minus 1 is 1, of course. 6 times 4 is 24. So we have 1 and 24 for the F1. So let's see, use the tabular table. So this is the table that we will be going to use. The title is the F critical values. Okay, the computed R is 1, while the computed what do you call this, RC N minus 1 is 24. So for the numerator, we have 1. Okay. For the denominator, we have 24. So we will look for the number 24. I hope there is 24 here. Okay, there's 24. Okay, then the 1. And then the given is 5%. So this is 5%. So the critical value is 4.26. I hope I'm correct. 4.26 is the critical value for this one. So let's see. 4.26 is correct. For the next one, for the F2, the formula is C minus 1, comma, RCN minus 1. The same with the, with the first F1. So we will use the same denominator, different numerator. So the numerator is C minus 1, so 3 minus 1 is 2. So we have 2 and 24. So dito tayo aalis, this is 2 and 24, that's 3.40. 3.40, correct? And for this one, again, we have the formula for the DF3, which is R minus 1 times C minus 1. The same formula for the denominator. So we have 2 minus 1 times 3 minus 1, and that's 2, and that's equal to 2. And then for this one, we have, of course, 24. So same with F2, F3 has a degree of freedom of, has a tabular value or the critical value of 3.40. Now, we will compare our answer to the given. Dito ba siya? Okay. So, these are the comparison now. The computed value, F1, which is 2.78, is less than the tabular value, which is 4.26. Hence, accept HO1 and reject HA1. The tabular value, which is 3.40, is less than the computed value F2, which is 6.54. Thus, HO must be rejected, and we will accept HA2. Obviously, the computed F3 value, which is 0.34, is less the tabular value, which is 3.40. We have a valid reason to accept HO3 and reject HA3. Therefore, for the conclusion, it only means that there is no interaction due to the sex and the method used in algebra. For the conclusion, actually we should have 3 conclusions here. Okay? We accept, okay, in the first part we accept HO, in the second we accept HA, in the third we accept HO. So we will go back to the first. So we will accept this one for the first what do you call this? For the first conclusion, we accept HO1. So the conclusion is there's no difference due to the methods used in learning algebra. For the conclusion number 3, there is no interaction because we accept HO. For the conclusion number 2, we accept HA3, that there is a significant difference between the sex. Meaning to say, there might be a possibility that boys excels in more in than female, or female excels excel on the than on the different methods than the male. Okay, so but obviously here I can see that male perform well because as you can see there are more higher than female. Okay, so that's all about for the analysis of variance, two-way classification. It is Actually, it is too laborious for you to do this type of statistical treatment. Okay, but there are other way now to compute for the Anova Two Way. You can use the Microsoft Excel or the SPSS. But for the sake of learning the theory, so this video was made for you. With that, thank you very much and good day.